Hello again, guys. Here's Smidge, the cutest unicorn you've ever seen. Okay, so 5.2, perpendicular bisectors. Second video in chapter 5. And a perpendicular bisector, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of a segment. Okay, so that means that wherever it lies on this handy-dandy segment right here, which is your perpendicular bisector, it's equidistant from all of these segments. Okay, so that means it's obviously going to cut through our midpoint, making these two pieces congruent. So the important thing to know about this is this only applies when the perpendicular bisector goes through the vertex of the triangle. Only applies when the perpendicular bisector goes through the vertex of a triangle. Okay, so we know that if CD is perpendicular to AB and AD is congruent to DB, then we can assume that CA, this segment right here, is going to be congruent to CB, this segment right here. That's, so, something else to note. If the perpendicular bisector goes through the vertex, it will be an isosceles triangle, right? Because these two lines, or these two legs of the triangle are congruent. If the perpendicular bisector goes through the vertex, only when it goes through the vertex, it will be an isosceles triangle. Okay, so let's talk about the converse of that then. Okay, this time, this will only apply if it's an isosceles triangle. Only apply if it is an isosceles triangle. So what we want to look at here is if AC is congruent to CB, which it is, look, it's an isosceles triangle, then you know that CD, line CD, is perpendicular, remember that's the symbol for perpendicular, an upside down T, to AB. And that we can now say AD is going to be congruent to DB. The gist of it is, it's a perpendicular bisector, it cuts these two sides in half. And these two sides will be congruent, and this will be 90 degrees. All right? So let's go ahead. We see that it's a perpendicular bisector, right? And we see that these two sides are congruent, which means that this is definitely an isosceles triangle. So if we want to solve for x, then we're going to set them equal. We're going to do 7x plus 24 equals 13x minus 48. I want to get my x's on one side, so I'm going to subtract 7x, and I'm going to end up with 24 equals 6x minus 48. I'm going to move 48 over and get 72 equals 6x. I'm going to divide by 6 and get x equals 12. You guys get to attempt this one. All right, I'm going to jump over here, and I'm going to find EG now. All right, I see that it's an isosceles triangle, right? Do you guys both see that it's an isosceles triangle? All right, that means this is perpendicular right? A 90-degree angle, and that these two pieces are congruent to each other. So I'm going to go ahead and solve. But remember, it's asking me to find EG this time. So I'm going to do 2x plus 11 equals 14x minus 37. All right, I'm going to move my 14 over, and I'm going to move my 37 over. I'm going to get 48 equals 12x. I'll divide by 12 and get x equals 4. Then I need to plug it in for EG, right? EG. So EG is going to be 2 times 4, right? I'm taking this 2x and replacing it with a 4 where the x's, and plus 11, 8 plus 11, and I get 19. EG equals 19. So of course, you guys guessed it, you get to attempt number 3. All right, and then I will go ahead and do number 4 with you. This time it's asking for AB. So again, I see that it's an isosceles triangle, so I know those are 90 degrees and I know these are equal. I'm going to solve for x by setting these two congruent pieces equal to each other. 5x minus 11 equals 3x plus 17. I'm going to move things around, and I'm going to end up with 2x equals 28. I'll divide by 2 and get x equals 14. All right, this time I need to plug it in, right? I can choose either of these to plug it into, but remember I'm finding AB the whole thing, so I'll need to times that by 2 in the end. So now I'm going to do my best. I'm going to find AD first, all right? And that's going to be 5 times 14 minus 11. When I do that, I'm going to get AD equals 59. All right, and now I need to find AB, so I'm going to need to take that 59 and multiply it by 2. So AB is going to equal 59 times 2. AB will equal 108. And of course, you guys guessed it, you get to do that one. Okay, so let's move on now to our angle bisectors. All right, 5.2, angle bisectors. Okay, if a point is on the angle bisector, then that point, wherever that is on that angle bisector, is equidistant from the sides of the angle. Let's see if I can get this to focus a little bit better. Not really. So what we're going to read here is we see that if AD, this segment, bisects angle BAC, this entire angle, AB is going to be perpendicular to the edges. So we get these two boxes, and we see that AC is also perpendicular. Then we can know, if we see that they're perpendicular, then we can know that BD is going to be congruent to CD. All right, so let's think about it in a different way. If a shared side of two right triangles is an angle bisector, then they will have congruent legs. If a shared side of two right triangles is an angle bisector, then they will have congruent legs. Okay, so let's now look at here. We know that BD this time is congruent to DC. All right, so that was the angle bisector, and now this is the converse. All right, this time we know that these two are congruent, and we see that these are right angles. They're perpendicular. That BD is perpendicular to AB, and that DC is perpendicular to AC. If we know that, then we know that AD bisects angle BAC. AD bisects angle BAC. So in layman's terms, if you have two right triangles with one pair of legs that are congruent, if you have two right triangles with one pair of legs that are congruent, and the other is a shared side, and the other is a shared side, the shared side will be an angle bisector. Okay, so angle bisectors. They cut an angle in half. If you draw a segment to the angle bisector from that angle, they will be congruent and they will also be perpendicular. So let's go ahead and see what we can find here. We see that they're perpendicular, right? We see the right angle, all right, and we see that the angles are congruent. So this must be an angle bisector. So in order to find x, I'm going to go ahead and I'm going to set them equal because I know based on the information they gave me that these pieces are congruent. So 4x plus 30 equals 9x minus 5. All right, I'm going to move things around and I'm going to end up with 30 equals 5x minus 5. And then I'm going to subtract 5, or add 5, sorry, and get 35 equals 5x. I will divide and get x equals 7. All right, I want you guys to try this one. We will do these final 4 in class tomorrow. So wait for the rest of them. All right, you do this one, wait for the rest of them. All right, bye guys.